The first question on your worksheet was f of theta equals 2 secant theta plus tangent theta on the interval 0 is less than theta, which is less than 2 pi. So first thing we have to do to find all extrema is find the derivative of the function. And so f prime of theta would be equal to the derivative of secant theta is secant theta tangent theta. This 2 is a constant, so it just gets carried down into the derivative. And then the derivative of tangent theta is secant squared theta. In order to find relative extrema or absolute extrema, you've got to first find where the derivative equals 0 and then find where the derivative is undefined. So we need to work on that first. So I'm going to set the derivative equal to 0. And what I noticed is both of the terms have a secant theta. So I'm going to factor it out. That leaves me with 2 tangent theta plus secant theta. And if we are solving for where the function, or excuse me, the derivative equals 0, then I can take each individual factor, set them equal to 0 separately, and solve from there. So I need to find out where secant theta equals 0 and where 2 tangent theta plus secant theta equals 0. And since I'm more familiar with the values of sine and cosine, I'm going to rewrite both of these in terms of those functions. So secant theta is the same thing as 1 over cosine theta. And then tangent theta is sine theta over cosine theta. And again, secant is just 1 over cosine. And that works out really well over here because I have a common denominator. So I can rewrite this as 2 sine of theta plus 1 over cosine of theta. And now I have 2 individual equations to solve. 1 over cosine of theta. Well, when I have a quotient or a fraction, the entire fraction or quotient equals 0 where the top, the numerator, equals 0. And the only thing I have on top here is a 1. 1 will never equal 0. So this function won't ever equal 0. However, it can be undefined. And remember, we're looking for critical values. And critical values are where it equals 0, but also where it's undefined. So I'm just going to go ahead and list where the derivative is undefined because I know I'm going to have to do it anyways. So 1 over cosine of theta is undefined where cosine of theta equals 0. And cosine of theta equals 0 at pi over 2 and 3 pi over 2. And I include both those values because they're within my interval they've given me. So for f prime of theta being undefined, we have theta equals pi over 2 and 3 pi over 2. So I've already got 2 critical values here. Let's go back over to this one. So this is a quotient, and to solve where a quotient equals 0, I only need to be concerned where the numerator equals 0. If the denominator equals 0, it's undefined, and we already have worked with that over here where cosine theta equals 0. So really all I need to solve is 2 sine of theta plus 1 equals 0. Subtract 1 from both sides, divide both sides by 2. And I am looking for where sine of theta equals negative 1/2. So this is the point where you really need to be familiar with your unit circle. On the unit circle, sine corresponds with y values. And if I'm trying to figure out what angle measure, the theta, would give me sine of theta equal to negative 1/2, what I'm looking for is where the y is negative 1/2 on the unit circle. So if I look at my unit circle, what I have below the x-axis is my negative y values. And I see that at 7 pi over 6, y equals negative 1/2. And at 11 pi over 6, y equals negative 1/2. So those are going to be the two solutions for my current problem. Those are within the interval. So theta equals 7 pi over 6 and 11 pi over 6. So my critical values for this function is pi over 2, 3 pi over 2, 7 pi over 6, 11 pi over 6. Now, to go from here, I have to find extrema. And first of all, we are looking at an open interval. There are not equal to symbols here. So on an open interval, we're not guaranteed absolute maximum and minimums. So that means that I do not plug these values into the original. I only do that for closed intervals. If it's open, I just go ahead to the sign chart. So looking at my critical values, I need to create a sign chart, which means I need to put them in ascending order. So I need to find the lowest and the highest. Now, let's say for a minute we're not able to work with our calculator. How would I put these in order without my calculator? Well, the way you compare fractions is you give them all a common denominator. So if I am trying to compare pi over 2, 3 pi over 2, to 7 pi over 6 and 11 pi over 6, I need to rewrite these as over 6. So pi over 2 is 3 pi over 6. 3 pi over 2 would be 9 pi over 6. So now I have them in order. I know 3 is the smallest value, then 7, then 9, then 11. So on my sign chart, this is going to be for the first derivative, so I note that it's for f prime. And I'm going to put my critical values in order. So 3 pi over 6, 7 pi over 6, 9 pi, and 11 pi. So those are my 4 critical values for my sign chart. Alright, so let's continue working on our sign chart as if we are not allowed to use a calculator. And so what we're going to need for this is 2 things. We're really going to need our unit circle, and we are going to need to rewrite our derivative in a form that will be most helpful to us, because right now there's too many terms, and if I'm trying to reason through whether it's going to be positive or negative, it's easier if I don't have to work with this. I can work with maybe a quotient or just a product of this times that rather than these plus signs. We're going to try to minimize the trig. So I'm going to take secant theta times 2 tangent theta plus secant theta, and I'm going to rewrite it to make it easier for when I'm testing values for my sign chart. So secant theta is 1 over cosine theta. And 2 tangent theta plus secant theta, well, I've already combined them into one quotient down here. So I'm going to rewrite that in the parentheses. And then when I multiply through cosine theta becomes cosine square theta. So my derivative is 2 sine theta plus 1 over cosine squared theta. And it's easier to work with something that looks like this, because if it's a quotient, I can think top's positive, bottom's positive, whole thing's going to be positive, rather than trying to work through this form of the derivative up here. So we have to reason through whether we are going to have increasing or decreasing on my intervals on my sign chart. And so that's where our unit circle is going to come into play. So 3 pi over 6 is just pi over 2. And we're looking for values that are less than pi over 2, which would be the first quadrant. And so in the first quadrant, I know that my x's and my y's are positive. So when I evaluate this for some value in the first quadrant, this will be positive and this will be positive. So that means that overall the whole quotient will be positive. Now, between 3 pi over 6, which is pi over 2, and 7 pi over 6, which would be pi over 2 to 7 pi over 6, most of that is in the second quadrant, which is where my y's are positive, my x's are negative. If I look at my quotient, this will be positive, and even though cosine of theta will be negative in that quadrant, it's squared, which makes it positive. So I still end up with positive over positive. Now when we move on to the next interval, 7 pi over 6 to 9 pi over 6, on my unit circle, I have 7 pi over 6. And then remember, 9 pi over 6 is 3/2 pi. So I'm looking at the third quadrant, which both my x and my y are going to be negative. So when I look at my quotient, 2 times a negative number plus 1 over a negative number squared. So the bottom is going to be positive because a negative squared is a positive. The question is, will this be a negative? Well, my y values here, if you look from 7 pi over 6 to 3 pi over 2, if I pick a value in between, it could be any of these. Let's say we pick 5 pi over 4. Well, my y value here will be negative square root of 2 over 2. So what I end up with when I plug that in here would be 2 times the negative square root of 2 over 2. And if you write it out, you see that the 2's eliminate. They divide out to equal 1, and you're left with negative square root of 2. Now the question is the negative square root of 2 bigger than 1? Because if it is, then that means that your numerator is going to be a negative value. And I don't have to know exactly what the square root of 2 is, because I know what the square root of 1 is. The square root of 1 is 1. So if it's the square root of 2, it's got to be bigger than 1, which means negative square root of 2 plus 1 is going to be a negative answer. So we have negative over positive, which gives me negative. Our last interval is 9 pi over 6 to 11 pi over 6, which is in the fourth quadrant. So 3 pi over 2 to 11 pi over 6 is in this fourth quadrant. And that makes our x positive, but our y negative. And so I can really think in the same way that I just did for my y values, because I still have a negative square root of 2 over 2 for a y value. And so I know if I plug it in up top, I'm going to get the same result. I'm going to get a negative answer in the numerator, a negative value. And then the denominator will always be positive because it's cosine squared. And so again, I have a negative over a positive, which makes it negative. And then the last piece would be 11 pi over 6 to 2 pi, because that's my interval, 0 to 2 pi. So in this region, what would be the outcome? Alright, so what is a y value that would exist between negative 1/2 to the x-axis? And a value that's between 0 and negative 1/2 is negative 1/4. So if I look at my quotient here, if sine of theta equaled negative 1/4, 2 times negative 1/4 would be negative 1/2. And negative 1/2 plus 1 is a positive. And then the denominator will always be positive. So positive over positive gives me positive. So where do I go from here? Well, now I have my sign chart. So all I have to do is look for changes from increase to decrease or decrease to increase. So what I see here at 7 pi over 6 is an increase to a decrease. And at 11 pi over 6, I see a decrease to an increase. And the original function is defined at those two values. So I know that those are going to be relative max and minimums. So let's see. I would say increase to decrease is a max. So relative max at theta equals 7 pi over 6. And a decrease to an increase is a minimum. So relative minimum at theta equals 11 pi over 6.